So we're in Chapter 7 now of Dr. Friedman's Physics 1 class, studying potential energy and energy conservation. You've already worked with Ken through part O of this exercise 7.37 in the text, right? You were asked to find the frictional force on the bag of gravel and on the box here. The bag of gravel is M1, the box is M2. And you found in part A that while the maximum tension is 67 G, the maximum static frictional force is greater. So that at least for part A, the system is not moving, therefore there is non-zero frictional force only on the box M2, and that is just Tmax. While the frictional force on the gravel, M1, is zero. We now want to look at part B. Suddenly the worker picks up the bag of gravel and we're told to use energy conservation to find the speed of the bucket after it has descended this given 1.6 meters. So now the gravel is lifted, so that there's no more M1 there. And in that case, what do we have? Well, the friction is now approximately, looks like 50-something. Goodness. 57.4 G. Which is less than Tmax, so the tension now pulls the system forward, and we have movement. The static frictional force is no longer strong enough to hold it there, and we can then address this question. Using the work-energy theorem, that the non-conservative work is equal to the change in kinetic energy plus the change in potential energy, given that the system starts from rest, so that the initial kinetic energy is zero. Let's solve this then for the total final kinetic energy. K, final, which you know is half a square meter V square plus half a cubic meter V square, while there is no longer an M1. And that's equal to the work done by the non-conservative force. Here friction, the change in the potential energy, whatever potential energies there are here. The work done by friction is mu sub K m2 G. That is the force of friction. And this dx is the distance over which the friction acts, and it acts in the direction opposite to displacement. So we have that for the first term here. And let's then just solve for that kinetic energy. G delta Y M3 minus mu sub K M2 looks like. Factoring out then to solve for the velocity squared. Looks like 2G delta Y over M2 plus M3 times M3 mu sub K M2. Tidying up, yes. There. We have all these numbers, so let's put them in. 2. Get 2 times 9.8 times 1.6 divided by 67 plus 82 times 67 minus 0.4 times 82. And this comes to about 7.2. Taking then the square root of that. Finally, we get that V is about 2.7 meters per second. That's the speed of the concrete, M3, as well as that of the box, M2. After M3 has descended this 1.6 meters. There.